Hello students, let's try to understand PCY algorithm. So PCY algorithm stands for Park Chen Yu algorithm. So these are the three scientists who developed this algorithm. This algorithm is used to find the frequent item sets from a very large data set. So it is one of the mining algorithms that works on the large data sets. So in field of big data, this is the algorithm to find the frequent item sets. Okay, now let's take one example in this. Let's say we have a collection of data, which is more like a transaction database or transaction data set. And we have the records of the customers who have bought the items. Okay, so here, if you look at this particular transaction table, there are four transactions, and in each transaction, some items are bought by the customers. We can clearly see that in all the transactions, the shirt is a common product that has been brought by many of the customers, and I can say that shirt is a frequent item set here. After shirt, we can see that jeans has been brought as the most frequent item in these transactions. So similar way, we have to find out such frequent item sets in data set. But as I said, as I mentioned earlier, our data set is a large data set. So likewise, we'll be having millions of transactions, and from these millions of transactions, we need to find the items which are frequently bought by customers. And we may even want to find out the relationship between these items. Like, for example, if a customer is buying shirt, what is the probability that customer is going to buy jeans with that or a trouser with that? So what is the probability of finding getting these kind of combinations? We have already earlier seen one algorithm in machine learning algorithms, which is a priori algorithm. So this is the extension of that algorithm. Few concepts we're going to apply the same way, but there are some additional concepts that we're going to learn in this particular algorithm. So let's try to understand what is a PCY algorithm. So in PCY algorithm, the question is we need to apply the PCY algorithm from on the transactions given to find the candidate sets. Here we apply PCY to get the candidate sets, right? So we're going to discard or reject those transactions or those items basically which are not considered as frequent. So here I have to gradually build up my candidate set, and whichever candidate set is not frequent, I can simply discard them. Okay, so let's understand one question from this. Given a question where there are total 12 transactions given, so there are total 12 transactions. In each transaction, you can clearly see that some items have been brought by the customer. There is a threshold value given. So here, this threshold value, you can also call this threshold value as a support count, right? So here the minimum support count is given, which should be 3, right? So that means any item which is found minimum 3 number of times, at least 3 number of times, we can consider it as a frequent item set. So anything from 3 onwards can be considered as a frequent item set. We have also given a hash function. So basically PCY algorithm uses a hash function which is used to map pairs to the buckets of hash table. Buckets of hash table. So here we are going to use this hash function, which will be used to map the pairs that we are going to generate from these transition tables, which will get mapped to the buckets of the hash table. And this hash table will help us to understand which candidate pairs are frequent pairs that we can take forward to the next phase. So let's assume the transition tables are given in this way. The transition table is this, and the transactions are given in this way. In each transaction, some items have been bought. Now, this is similar to a priori. So we know the first step. Whenever the transaction table is given, we need to generate the one item set, right? So from this, the basic phase will be here. That first thing that we're going to do is we're going to find out the one item set. Okay. And once we find out the one item set, we're going to find the length of that one item set. Now, length here in this case, we are finding out the number of times it was observed. Okay. So number of times it was observed in the table. So this is how we're going to create the one item set. From one item set, then we find out the frequent item sets, which is a candidate set, and we continue that to get two item sets. Here, whenever we are going to create these item sets, we're going to also find out whether those item sets will contribute as a candidate sets which are frequent in the system. But before that, let's try with the first step. Along with this, while we perform this operation, we're going to also find the candidate sets which are frequent with respect to the hash function given. So the very first step is very simple way. We are going to just first generate the one item set. One item set means I'm going to identify the length of the candidates in the given data set, and I'll start with having length as 1 and then I will increment it. Okay. Also, then later on, I will also get the pairs. I'll generate the pairs and I'll map these pairs to the hash table. So I will apply a hash function and I will map these pairs to the buckets, and then I will draw the candidate sets from that bucket. So this is what basically the solution for identifying the frequent item sets. So first step, we're going to map all the elements in order of their length. So there are total, if you look at the table carefully, if you want, you can take the screenshot of this table. So there are total 12 transactions. And if I want to identify the unique items of this table is 1, 2, 3, 4. So it's 1, then we have 2, then we have 3, 4, 5, and 6. So these are the items which are present. These are the unique items in my entire table. Okay. So my the first set, that is one item set, will be 1, 2, 3, 4, 5, 6. So I have total 6 items. So I've written them 1, 2, 3, 4, 5, 6. Now you have to also find out the value, how many times these items were found in the table. So let's find out item 1 was found in the table. How many number of times? So let's count it. So it is 1, 2. So I'll just take another color. Okay, so here it is 1, then 2, then 3, then 4. Okay, so it is observed 4 number of times. So we're going to write it as 1 is observed 4 number of times. So it is not frequently observed. Let's just find out how many times that item was found in the table. So it is found 4 number of times. Now let's find out item number 2. How many times item number 2 was found? So this is item number 2, 1, 2, 3, 4, 5, and 6. Okay, so again, one more time, I will cross verify. 1, 2, 3, 4, 5, and 6. So 2 was observed 6 number of times. So 2 is observed 6 number of times, right? Likewise, you will do it for 3. 1, 2, 3, 4, 5, 6, 7, 8. So 3 is observed 8 number of times. So likewise, you have to do it for all the 6 elements. So 4 is observed 9 number of times, 5 is observed 5 number of times, and 6 is observed 4 number of times. Now, once you get the total count, that means the total number of times these elements were observed, now we will apply the minimum threshold value that was given. In the question, it is given as 3. So minimum support is given as 3. That means if any element is found lesser than 3 times, we are going to discard it. But as of now in our table, if you see, none of the elements have been observed less than 3 number of times. So we're going to continue them in the next step. In this case, if in a question you got such elements which has value lesser than the threshold value, you're going to simply discard them. Do not send it forward to the next step. Okay, just for example, 6 coming 2 number of times, I will simply discard 6. I will not consider in the next step. Otherwise, just forward as it is in the next step. Now, once you do that, that means the set has been now introduced in the next step. What we have to do is we have to calculate the lengths of the candidate pairs of the step. That means from your transition tables, you have to now form the pairs, that means the candidate pairs, because they are all the frequent item sets, right? And they are individual items. So not going to map them. We're going to map their pairs to the bucket. So in the first step, you don't have to map individual items to the bucket. In the second step, once you will get the candidate pairs, those candidate pairs will now get mapped to the buckets. Okay, so let's create the pairs. Now, again, you go back to your transition table. Okay, now in T1, because 1, 2, 3 all are frequent item sets, so basically you need to create pairs. What possible pairs we can generate from this set having 2 item sets. So I can have first pair, which is 1, comma 2. So this is my first pair, which is 1, comma 2. Another pair that I can find from this is 1, comma 3. And another pair, next pair, which I can find out from this is 2, comma 3. Right. So if you see, okay, so from 3 item sets, I get 3 pairs of 2 item sets. That means from individual items, now I have paired them together to get 2 item sets. Right. Similarly, you are going to do it for the remaining pairs also, but you have to keep in mind, do not repeat the pair. So if you think that that pair has already been generated in the earlier transaction, uh, earlier entries, do not repeat it. For example, here, 2, comma 3, comma 4. The pair that will be generated is 2, comma 3, 2, comma 4 and 3, comma 4, where you can clearly see 2, comma 3 has already been generated in the earlier transaction, so you don't need to repeat that. So you're just going to write 2, comma 4 and next is 3, comma 4. That's it, right? So here I'm getting 2 pairs. Why we are not repeating? Because anyways we have to find out their occurrence in the entire table, so it's common, right? The table is common, that's why we don't need to repeat it. Otherwise you'll have to repeatedly write the support count and repeatedly cancel it out if it is not a frequent item set. So no need to repeat it. So likewise, for every transaction, whatever sets have been allocated to that transactions, you generate a candidate pair out of that. Yes, it may happen that one of the uh, items have been discarded in the earlier stage. If they are not frequent, then you don't need to create their pairs. For example, here, if I say that 4 is not a frequent item set, so any pair which is generated from 4, you don't need to consider that. So for that matter, 3, comma 4 will not come in the picture. So you have to be very careful while you are, drawing these candidate pairs from the individual sets, because if the item is not frequent, you don't have to consider it for the candidate pair also. Here we don't have that problem because all our items are frequent item sets. So we have to generate the pairs from each transaction. So in the next step, if I'll show you here, in the next step, we have generated all these pairs. And as I said, we don't have to repeat it. So T2 had 2, comma 3, which we have not written here. So it has only 2, comma 4, 3, comma 4. Even T3 has some repetitive entries, which we are not considering. We are writing all the new entries. So likewise, you will get all the new entries. You're just mentioning all the new entries in the next way. So here T10, T11 and T12, they already have entries which are coming from these entries. So we don't have to write them again. Now, once you do that, you also need to write their support. Now, this part is called as a support. Okay, so this is a support that you're going to write. Support means, again, from the transaction table, how many times that pair has been observed. For example, 1, comma 2. How many times 1, comma 2 is observed from your table? So let's try to find out 1, comma 2, how many times we found it. So I'll just erase this part now. So let's search for 1, comma 2 now. So this is 1, comma 2. This is 1, comma 2. So you can clearly see that 1, comma 2 has been observed 2 number of times. So the support of this particular pair becomes 2. Next pair is 1, comma 3. So let's find out how many times 1, comma 3 has been observed. So 1 is this, then 1, comma 3, then 1, comma 3, and that's it. So 3 times. So this pair has been observed 3 number of times. And then third, let's say 2, comma 3. So this is 2, comma 3, this is 2, comma 3, and this is 2, comma 3. So this is also observed 3 number of times. So likewise, for every occurrence of the pair, you need to count how many number of times that pair has been occurred. So in this way, you're going to write the support count. Either you write along with the pair or just equals to and then assign the value support count. That is just for our references. So we have written the support count of all the pairs here. Now, once you write the support count, the next step we have to repeat again, right? Once we found the support count, we need to check the threshold value. Here, only those pairs will be frequent pairs whose support count is greater than equal to 3. So likewise here, if you see 1, comma 2, 1, comma 2 is not satisfying the value 3. It has support count 2. That means it's not frequent. So we're going to simply discard this. So any pair which is not satisfying the support count minimum value, which is 3, we are going to discard it. So like here 5 comma 6, because its support count is 1. 1 comma 5 support count is 1. 2 comma 6, 1 comma 4, 2 comma 5. None of these pairs are satisfying the minimum support threshold, that is 3. So we're going to discard them. So let's transfer the remaining pairs to the next step. Now here, because we found the candidate sets from the this particular step, now we need to map these steps because these are pairs now, and we know that what we need to do with the pairs, we need to map them to the hash function. So let's take forward these pairs. That means these are my frequent pairs which I got after rejecting the one which have lesser value, lesser support value. Now what I need to do is I need to apply a hash function on these pairs. So let's apply a hash function. So we are aware how to apply a hash function. It is given in the question. The hash function is I into j mod 10. So I and j, ij is your pair, I is 1, j is 3, 1 into 3, that is 3, 3 mod 10 is 3. So a similar way, you're going to create hash value for all the pairs in your set, which are frequent pairs. Once you get these values, now please pay attention. Now these values are nothing but your bucket numbers in your hash table. Now our hash table size is 10. So here it is written in hash function, right? We are performing mod 10. That means my table is of size 10. That means I get a value of first hash uh, entry as 0 or bucket as 0 and last bucket is 9. So 0 to 9 buckets I am getting in that hash table, and in these buckets my pairs are going to map. So these are the values of the buckets to which that particular pair will go. So if you see here, 1 comma 3 goes to bucket number 3. So if you see here, bucket number 3, 1 comma 3 goes into that bucket. 6 is a bucket number where we are going to put 2 comma 3. Okay, so these are the buckets 0 to 8. I think it is 0 to 8, but it should be 0 to 9. So there is one more bucket here. Okay, so I'll just write here. It is 0 to 9. And then in 0 to 9, I think there is no bucket which is mapped. So it is simply dash. Okay, so we are only utilizing 0, 2, 3, 4, 5, 6, 8. These are the bucket numbers and to which the pairs have been mapped. Now, a hash table does not store pairs. It just stores the frequent support count of that pair. So here the bucket number 0 holds the support count of 4 comma 5, and we know that 4 comma 5 was observed. If you look at this table, you will know that 4 comma 5 was observed 3 number of times. So bucket 3 is going to hold the support count of 4 comma 5, which is 3. So last step remains is you have to prepare this kind of a table which shows a bit vector, which shows all the bucket numbers from 0 to 9. Again here it should be 9, right? And then all the high support count, that means the support count of that particular bucket. What is the support count that we are finding? Then pairs, what pairs have been mapped to that bucket, and then the candidate set. Now candidate set is formed from the pairs itself. Now because our pairs are only 2 item sets and there are not more than one pair has been mapped in a bucket, so I can't create a candidate set from this. Like for example, here I have given it in notes that if a bucket has more than one pairs, then we need to perform 3 item sets from those pairs, right? So, and we have to repeat the process in the similar way. So I'll give one example here. Like for example, let's finish this question. Right now, these pairs have been mapped into these buckets. So the bit vector of that particular bucket will be 1. The remaining bucket will be 0 in this case. So if you see, there is no pair coming in the bucket 1, so its bit vector is 0. No bucket which is coming in 7 and no bucket which is coming in 9. So those values will be 1. So if you write it down, this is your bit vector that looks something like this, which is 1, 0, 1, 1, 1, 1, 1, 0, 1, 0. So this is your final bit vector that you get from this problem. So this is the final vector, bit vector. Sometimes the question they ask, show the final bitmap of PCY algorithm. So this is the final bit vector map. Okay, so this is what these are the pairs. Now your last step remains is you have to also find the support count of these buckets. If any bucket is not having the minimum support count, that bucket will be discarded from the next iteration. So let's say 4 comma 5 had a support count of 2. We would have rejected this bucket. This will not go in the second phase. As of now, you see all the buckets are satisfying the minimum support count, which is 3. That means any pairs that map to that bucket are frequent buckets. Okay, are frequent pairs. So here all these pairs are frequent pairs, and that's why they will go to the candidate set. Any bucket which doesn't satisfy the minimum support criteria, they will not be going to the candidate set. Also, next thing is, if a bucket has more than one pair, for example, if this bucket has two pairs, 4 comma 5 and 1 comma 2. So its candidate set will be now 4 comma 1, 4 comma 1 comma 2. That means you need to form all the combinations of three item sets. So this is first item set, then second could be 4 comma 5 comma 2, sorry, 4 comma 5 comma 2, and the next can be 1 comma 2 comma 5, right? So similarly, you have to do it for any buckets which has more than one pair. Right now, this problem is not ours because in each bucket we have a single pair. So there cannot be any more candidate sets that can be created from this bucket. And henceforth, in this case, in this particular case, these are the frequent items or candidate pairs which we found, which can be considered as a frequent candidate pairs in the given problem. So that's it. Your final answer will be the bitmap, the final bitmap, right? So here I can clearly see bucket number, second bucket and the last bucket and the middle bucket does not have any pairs mapped. Okay. And these are my candidate sets, which are frequent candidate sets. So this should be your final answer. If you think that there are more pairs that can be generated from the given buckets, so I can get more candidate sets, then you'll have to continue the problem for those candidate sets. So thank you so much.